Hey students, this is the second video I'm making about how to use the Desmos graphing calculator. This is going to be about how to graph continuous functions. If you want to graph discrete functions or sequences, you might want to go back and watch my other video. I covered this in the first video. I'm going to turn off my minor grid lines and I'm going to make my x and y axes count by ones. You can always change this if you don't like it like that, or depending on the data you're looking at, you can choose settings that'll make sense to you. So let's say that I want to graph a continuous linear function. So Desmos can graph a continuous linear function in all types of forms. I could graph y equals 8x minus 3. And you might recognize that as an equation in slope-intercept form, where our y-intercept is at 0, -3, and my slope is 8. So if I start at -3, I would rise up 8 and run over 1, and that would bring me to my next point here at 1, 5. There we go. I keep missing it. It's there. There we go. So I could graph that way. I can also graph using function notation. So I could say like f of n, or I could say f of x, doesn't really matter, is 8x minus 3. And so you can see those graphs lie on top of one another. I could turn one graph off or on without deleting the equation that I wrote, but we expected those to be the same graphs. And I could also graph, for example, let's say that instead of starting at my y-intercept, let's say that I graphed the equation from that ordered pair 1, 5. So I could have graphed this as like f of x equals, let's say I started at 1, I started at 5, the y value 5, and I am adding 8, and the number of times I'm adding 8 is always 1 less than x. So you might recall from units 1 and 2 that these equations, all three of these equations are the same. We could see that all three of these lines lie on top of one another. Okay, so again, once you have your graph, you can drag the screen around to change the view. You can come over to the wrench and change what portion of the x and the y axis that you see. You could also zoom in with the plus sign or zoom out with the minus sign. And if you ever get really far away from the settings you want, you could hit the home button to go back to the default view. So I'm going to leave these graphs here, but I'm going to turn them off so that we're not looking at them. And now if we wanted to graph an exponential function, a continuous exponential function, I could graph it in the form of, like, let's say I graphed f of n is, let's say that our function starts on the y-axis as, let's say the number 4, and that the common ratio or growth factor is 2. So I could graph the function this way. And again, I might be interested in zooming out. Oh, interesting. I noticed that function never seems to dip below the x-axis. I could graph my function that way. I could use y and x. So y equals, let's say 4 times 2 to the power of x. The way that I'm getting to the exponent here is on my keyboard. I'm hitting Shift 6, which brings up the caret button, but you could also bring up this keyboard down here. And so you could type down here like y equals, I'm going to do a different one. Let's say 2 times, oops, that was a 3, not a 2. 3 times, let's say 5. Now if I need an exponent, and it's not the exponent 2, I'm going to select this right here where it says a to the power of b. That's just going to cause me to have an exponent there. I can make it x. All right, so these graphs are not the same. I could see this graph starts at 3 and has a growth factor or common ratio of 1/5. So Desmos is a helpful tool for graphing. It's a little bit more intuitive than a graphing calculator. And as we discussed in class, the PSAT and SAT have now gone to Desmos as their default calculator.